Title is Narain to Narnia, and we start with the elevator pitch. And okay, great. So please start.
Thank you very much to the organizers for this beautiful and very inspiring conference. And thanks very much for inviting me to give this talk. This is based on a work, this following work done with these great collaborators, Nathan Benjamin, Christoph Keller, and Hiroshi Oguri. The title is Narain to Narnia. Narain, we almost immediately get to it. For Narnia, maybe we wait a little bit towards the second half of the talk when we hopefully travel to Narnia. Okay, so let's start with the elevator. So the main motivation for this work, for this talk, is the discovery of new instances of holographic dualities. So very recently, during the past couple of years, there have been new instances of holographic dual holographic theories. One is the case where we have on one side of the duality an average over quantum mechanical system, and a quantum mechanical system which is dual to a two-dimensional theory of quantum gravity, Jacques-Yves gravity. More recently, this new phenomenon was observed in one higher dimension. This was the following two works done last summer, where now the discovery is that an ensemble average over a family of two-dimensional cohomorphy theories is dual to a particular three-dimensional theory. This is the Chern-Simons theory coupled to topological gravity, and the two-dimensional cohomorphy theory is just a simple theory of free bosons, also known as Narain conformorphy theories. This was a very interesting discovery and has brought a lot of interest in trying to understand the origin of this new type of duality. So we have many questions to ask. Why and how averages emerge in holography? Where does it come from? In the usual, in the canonical ADS CFT correspondence as a holographic duality, we have a fundamental understanding construction of the setup. We have a string theory construction, a macroscopic construction, and we look at two different limits. In one limit, we have a conformorphy theory, one particular conformorphy theory, and on the other side, we have a particular theory of quantum gravity. And this has been started with work on Maldacena, has been studied for more than 2 decades. A lot of interest, progress in the field has been during the past time. So on the other hand, in this new type, we do not yet have a fundamental understanding of this duality. So this is a question that where does it come from? How does it emerge? And also to what extent this duality holds. In this talk, I'm going to talk about the second question, namely to what extent this holds. This is the reason this is rather the first easy approach one takes after seeing this discovery. So then one would like to search a little bit more to see, okay, to what extent this holds. In particular, when we talk about two-dimensional conformal field theories, there are a lot of interesting families of these theories known, which have a moduli space associated with them. We'll talk about that in more detail. A moduli space where each point, it's a space, it's a manifold called also a conformal manifold. Each point on this space is associated to one particular conformal field theory in this family. So we have families of conformal field theories, moduli spaces. We can study averages, and we can try to study in a holographic setup, the dual theory of gravity in the bulk. So this will be the focus of my talk today. In particular, in this work, we studied 3 possible generalizations in order to explore the range and the extent to which the duality holds. One particular case is the so-called toroidal orbifolds. We'll talk about it. One takes quotients of torus conformal field theories. These torus conformal field theories is exactly the instance studied in the previous work. So one can just consider discrete symmetries of this group and quotient by that construct orbifold conformal field theories. And so these also have nice moduli spaces associated with them. They're a little bit more complicated. There is more structure in there. So one might ask, does it hold? And the answer is yes, it does. And because of this extra structure introduced by the action of the orbifold, as we will see, there's also new beautiful structure showing up in the holographic interpretation, in the bulk story of the theory. There are more interesting families of conformal field theories in 2 dimensions, in particular families of supersymmetric theories. So we have sigma models on K3 and Calabi-Yau 3 or higher dimensional manifolds, where again, there are moduli spaces associated with them. And we can ask in principle the same question. So far, the answer turns out to be no, namely that the duality does not hold there. And I'll describe when we get there why. Also, there are other very interesting conformal field theories, rational conformal field theories, which we like them very much because one can solve them exactly. One has all the information about such theories. Again, one can ask the same question. Here is a little bit different because we do not have a moduli space. These are particular points. These are particular points of data. So one defines a way to take an ensemble of these theories and ask the same question, whether there exists, whether this holographic, this type of holographic duality emerges. The answer here is this, a triangle means that it only holds for certain cases. It's not a general, so far what we have studied, and a lot of other interesting work since then has been exploring this direction. It seems that for some cases, for some families, this holds, but not as a general rule. So this is basically the main topic of this talk. There are also other very interesting ways to explore this type of holographic duality. I mentioned a couple of them during the talk. However, very recently, there was a very interesting talk by some of the organizers and participants of this conference, a very interesting work on the lattice construction, and there will be a talk. And of course, I'm looking forward very much to hear about progress in that direction. So I think this is it for the elevator